Stellar energy and star power is what we learned about this quarter. The graph and the table have their points. For example, A through V dash B and so forth are the parts of the world, and the numbers are the amount of solar radiation that the Earth receives from the sun. It has always been questioned, which star gives more energy to its planets? Which one is stronger, powerful, bigger, and more powerful? Well, we know HR 87 is bigger than our sun, but that doesn't matter. We know which one is more powerful. HR 8799. Now think about it. If you have to block off some of your star's light and power, you know it gives off more light. Like we have to dim HR 8799 a lot to even see the planets. That just tells you that that star is way more powerful than our sun. Also, if you look at the sizes on this graph right here, you have to zoom in a lot to even see our stars and planets. In space, our planets are visible from a big distance, and you don't even have to dim our star to see our planets. That just shows you how big and powerful HR 87 is. The dots these dots are HR 8799. This shows that the radiation and the energy that the planets in the HR 8799 universe receive more radiation than our sun does. That our sun gives off. In the universe, or in the galaxy or solar system of HR 8799, it'd be more likely that you would get sunburns because the radiation and energy that the star gives off is much more than our sun does. So it'd be easier to get sunburned. It'd kind of be like living on Mercury, but like 10 times hotter. And you would always be getting lots of sunburns because look, compare, see, super big, super small. The radiation goes way higher than ours. So what gives us sunburns is low compared to what HR 87 gives off. And if you're like right here, it's like really close, it will burn you really easy. You get like 3rd-degree burns, 2nd-degree burns with the sunburns that the HR 87 will give off. These photos have helped me understand the concepts of Earth and our solar system and HR 8799's radiation. First off, this photo right here helped me understand the radiation and energy that the sun gives us during the seasons. So during June, we get our part of the world gets this much radiation, and in March we get this, in December we get this, and in September this is how much we get. And that helps me understand the radiation. And these two are together again to show me how much radiation is coming to the Earth from the sun. And this is showing during this point in time how much solar radiation and amount of sunlight we are getting. So the North America gets kinda a lot. Doesn't get the higher north, the more south you are. So from like here, Emilio, and you're up, you don't get a lot. During from here, like here to here, you get a lot. And here, you're like okay. But the most you get are right at the equator and below the equator. And there's a graph of all of that. And then here shows us the amount of radiation and energy, wavelength, and intensity that HR 8799 gives off and our sun gives off. And in the phases of ultraviolet, visible, and infrared. And our sun doesn't give that much, but HR 87 gives a lot off. These are how these photos have helped me understand the sun, our solar system, and HR 8799. If I heard a person say that when in winter the earth is farthest away from the sun, I would tell them that is incorrect because earth never moves like far away, it just moves in a circle. Like this is in a circle. And when you're in winter, it's the part of the season you're in when the sun gives more light than the other side. Like during June, the western hemisphere gets more. In like December, the eastern hemisphere gets more sunlight. So we are never moving farther, we're just going in a circle and the earth spins around. So I would tell them they are incorrect. Also, winter is not when earth is farthest from the sun, because like Australia and the other sides of the world are in summer while we're in winter. So they're just on the other side of the world and they're getting more sunlight than we are. And that is what I would tell them, and that is how you would explain, how I explain the way that the Earth orbits the sun in the seasons. This is star power and stellar energy.